Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, playing with the numbers topic we are going to continue. So our today's concept is divisibility tests of natural numbers. So in the earlier days, we used to suppose if you want to find whether a number divides the given number or not, or if you want to test whether or not a number is divisible by other number or not. So we used to perform actual division and we used to see whether the remainder is 0 or not. By that we used to tell it is divisible by so and so number, it is not divisible by that number, like that. But this is a time consuming process. So for telling like that, it will take lot of time. So our mathematicians, so they have proposed some divisibility tests or divisibility rules to check whether or not a number is divisible by certain given number or not. Whether a number x is divisible by the given number y or not. For checking that, our mathematicians, they have proposed some divisibility tests. Using the divisibility test without actual division, directly just by seeing the number, we can tell whether the number is divisible by given number or not. So in today's video about that divisibility test we are going to learn. So divisibility by 10. Divisibility by 10. So here any number is divisible by 10 if its last digit or units digit is 0. Units digit is 0. Suppose we have numbers like 230, 1580, 23,740. In these three numbers, the digit which is in the units place is 0. In the three numbers, the digit which is in the units place is 0. So these three numbers, without dividing by 10, directly we can tell they are divisible by 10. Whereas if you observe the numbers like 239, 1576 or 23,458, in these three numbers, the digit in the units place, here it is 9, here it is 6, here it is 8, means not equal to 0. So they are not divisible by 10. So none of these numbers are divisible by 10. So like that, just by observing the digit in units place, we can tell whether it is divisible by 10 or not. This is the divisibility test for 0. If you want to check whether it is divisible by 10 or not, we have to test what? We have to test the digit in the units place. So it is called divisibility test by 10. Next, in the same way, if you want to check the divisibility by 5, what we have to check or what we have to test, the last digit or unit digit is 0 or 5, because any number is divisible by 5 if its last digit or unit digit is 0 or 5. So if you take numbers like 230, 475, 1020, 23,485, here the unit digit is 0, here 5, here 0, here 5, means they are having either 0 or 5. So these four numbers, without actual division, we can tell they are divisible by 5. Whereas if we see numbers like 237, 1248, 13,786, here last unit digit is 7, here 8, here 6. So they are not having 0 or they are not having 5. So they are not divisible by 5. None of them is divisible by 5. So this is the divisibility by 5 rule. Suppose we want to check divisibility by 2. Already we have learned in types of natural numbers. Any natural number which is divided by any natural number which is having 0, 2, 4, 6, 8 in their units place is an even number, or any number divisible by 2 is considered to be an even number. Means a number is divisible by 2 if its last digit or units digit is divisible by 2. Suppose 786 is there. We want to check whether it is divisible by 2 or not. No need to check total number. Just in units place we are having 6. Just we can check that units place digit. 2 3 times 6. So the digit in units place is divided completely. So the number also will be divided by 2 completely. Like that we can tell. So if its last digit, if its unit digit is divisible by 2, then the number is divisible by 2. Or else if the unit digit is either 0, 2, 4, 6, 8, any one of these digits, then also it is divisible by 2. If you observe these numbers, 120, 372, 2584, 3786, 45988, here unit digit 0, 2, 4, 6, 8. So directly we can tell they are all divisible by 2. They are all divisible by 2. So whereas if you have numbers like 121, unit digit is 1, 233, 3, 2575, 5, 37,777, 7, 38,359, 9. In the units digit, we don't have 0, 2, 4, 6, 8. So they are not, or none of these numbers divisible by 2. They are not divisible by 2. So this is the divisibility rule by 2. Next, divisibility by 4. Divisibility by 4. So a number divisible by 4 if the number formed by its last 2 digits. What are last 2 digits, children? Units digit, tens digit. These two are considered as last 2 digits. If the last 2 digits are divisible by 4, then the total number is divisible by 4. It may be having any number of digits. No need to bother about that. Just we have to test last 2 digits of the given number. Suppose which of the following numbers are divisible by 4 in this question? First one, 3,50,736. This is a big number. We want to check whether it is divisible by 4 or not. No need to divide total number. We have to take last 2 digits. Units digit 6, tens digit 3. So we have 36 with 4. 4 9 times 36, 0. So last 2 digits are exactly divisible by 4. So the entire number is divisible by 4. This one, in this number also, last 2 digits 82. But 82 is not divisible by 4. So the total number is not divisible by 4. So this is the divisibility rule by 4. Next, divisibility by 8. Divisibility by 8. Divisibility by 8. So a number is divisible by 8 if the number formed by last 3 digits. In the case of 4, we have taken last 2 digits. But in the case of 8, we have to take last 3 digits. What are they? Units, tens, hundreds. If the last 3 digits, the number formed by last 3 digits, if it is divided by 8, then the total number is divisible by 8. So example here, which of the following numbers are divisible by 8? You are having this first number, 78056. what are last 3 digits? 056. But 056, 0 is extreme left. If we have 0 to the extreme left, then it will be not having any value. We can write it as 56. 56 is divisible by 8. 56 is divisible by 8. 8 7 times. 56. 0. 56 is divisible by 8. So total number is divisible by 8. Or this number, last 3 digits, 148. Last 3 digits, 148. But 148 is not divisible by 8. So total number is not divisible by 8. Like that we can tell. Next. Divisibility by 3. Divisibility by 3. So here, a number is divisible by 3 if the sum of its digits is divisible by 3. If the sum of its digits is divisible by 3. Suppose here one example we have, which of the following numbers are divisible by 3? So what we have to do? We have to find the sum of all the digits. 7, next 5, next 4, next 2, next 0, next 6. We have to write all the digits. We have to write all the digits. So then we have to take their sum, which is 24. This 24 is divisible by 3 because 3 8 times 24. So that's why total number is divisible by 3. If the sum of all the digits is divisible by 3, then the number is divisible by 3. This number, let's take the sum of all the numbers. 8, 5, 3, 7, 0, 1, 4. Sum of all the digits is 28. That is not divisible by 3 because 3 9 times 27. 3 times 10 times 30. So 3 cannot divide 28. So total number is not divisible by 3. Total number is not divisible by 3. Next. Divisibility by 9. Divisibility by 9. So a number is divisible by 9 if sum of its digits is divisible by 9. Means divisibility by 9 is same as divisibility by 3. Both are same. So which of the following numbers are divisible by 9? Let's do their sum. 6, next 7, next 3, next 2, next 0, next 1, next 8. Sum is 27. 9 3 times 27. Divisible by 9. So total number is divisible by 9. This number, all the digits. If we write all the digits and take their sum, it is 32, which is not divisible by 9. Therefore, the total number is not divisible by 9. Next, divisibility by 11. Divisibility by 11. So, a number is divisible by 11 if the difference of sum of digits at the odd places starting from ones place and the sum of digits at even places starting from tens place is either 0 or divisible by 11. Is either 0 or divisible by 11. Means, suppose which of the following numbers are divisible by 11? Suppose if we have this number 57324 So what we have to do? We have to do the sum of the digits at odd places. Odd places means units place, that is considered as odd place. After that, we have to leave one place, next place, hundreds place, next leave one place, next place, 10,000s place, like that, one by one. Until means if the extreme right position, unit position is considered as 1, Units position is considered as first position, then tens second position, hundreds third position, thousands fourth position, 10,000s fifth position, like that. So 1, 3, 5 are odd numbers, are considered as odd positions. In units place we have 3. In hundreds place we have 2. In 10,000s place we have 7. So odd places, the digits in odd places, we have to take their sum. 3 plus 2, 5, 5 plus 2, 12. And even places means second place, fourth place. Means starting from tens place, thousands place, next lakhs place, like that. If we do their sum, tens place 4, thousands place 3, lakhs place 5, like that we have to add them. Their sum is 12. After taking the sum of both odd places and even places, now we have to do their difference. 12 minus 12, 0. If the difference is 0, or if the difference is like 11, 22, 33, these are all divided by 11. If the difference is 0, or if the difference is divided by 11, then the total number is divisible by 11. Next, second one. So 5, 8, 6, 9, 2, 1. This is 1, 3, 5, 7. 5, 6, 2, 7. Or from here, from right side, 7, 2, 6, 5. 7, 2, 6, 5 are the odd places. We have to do their sum. How much? 20. Next, 1, 9, 8 are even places. 1, 9, 8 are even places. We have to do their sum. 18. Now, these two numbers difference we have to do. 20 minus 18, 2. 2 means it is not divisible by 11. So total number is not divisible by 11. Next, this number. So 2, 0, 1, 0, 0. So 2, 0, 1, 0, 0. How much? 3. Next, even places. 5, 4, 3, 5, 8. So 5, 4, 3, 5, 8. Their sum is 25. Now, these two difference. How much? 22. 22 is divisible by 11. So total number is divisible by 11. So this is the divisibility rule for 11. Next, divisibility by 6. Divisibility by 6. So a number is divisible by 6 if it is divisible by 2 as well as 3. 2 as well as 3. Suppose this is the number. Last digit is 2. So it is divisible by 2. What is sum of the digits? 5 plus 3 plus 0 plus 2 plus 2, 12. Divisible by 3. So it is divisible by 2. Because last digit is 2. It is divisible by 3. Because sum of all the digits is divisible by 3. So as it is divisible by both 2 and 3, it is also divisible by 6. Because 6 is a combination of 2 into 3. 6 is a combination of 2 into 3. It is divisible by both 2 and 3. That's why it is divisible by 6. Or this one. Last digit 4 divisible by 2. What is sum of all the digits? 7 plus 5 plus 1 plus 0 plus 2 plus 4, 19. Not divisible by 3. So, not divisible by 6. Next. So, in 3791 asterisk 5, we have asterisk symbol here. Replace this asterisk symbol by a digit so that the number formed is divisible by 9. Number formed is divisible by 9. How to check whether it is divisible by 9 or not, we have to do the sum of all the digits. If it is divisible by 9, then total number is divisible by 9. So here 3, 7, 9, 1, asterisk 5. So let's take their sum. Take their sum. 5 plus 1 plus, from here 5 plus 1 plus 9 plus 7 plus 3. So asterisk we are not considering, which is 25. 25. But 25 is not divisible by 9, because 9 2 times 18, we are getting 7. Means if we add what number, it will be divisible by 9. For 7, if we add plus 2, then we will get 9, which is divisible by 9. Means for 7 plus 2 we have to add, means for this 25 we have to add plus 2 and we have to make it 27. So then 9 3 times 27, 0. Directly we will get the value. So if we add 2, then it becomes 27 divisible by 9. So in the place of asterisk, there should be 2. So then this number is divisible by 9. Like that we can guess the missing number. Next. So what we have learned, children, divisibility by 10 means units place 0. Divisibility by 5 means units place 0 or 5. Divisibility by 2 means units place 0, 2, 4, 6, 8. Divisibility by 3 means sum of all the places, units, tens, hundreds, like that, all the places to be divisible by 3. Divisibility by 9 also same. Divisibility by 9 also same. Divisibility by 11 means sum of sorry, 1 minute. One minute. So divisibility by 11 means sum of odd digits like 1, 3, 5, 7. Suppose this is sum 1, S1, and sum of all the even digits 2, 4, 6, 8, let it be S2. The difference of these two, S1 minus S2. Suppose if this is a S, if this S is divisible by 11, then total number will be divisible by 11. Or if this S is 0, the difference of these two is 0, then also it is divisible by 11. Next, children, deciding whether the given number is prime or not. We have to check whether the given number is prime number or not. So in a previous class we have discussed what is prime number. The number which is having factors only, like 13. The number which is having factors only 1 and itself, they are called prime numbers. So let n be any given natural number which is greater than 1, because 1 is neither prime nor composite. So that's why we have to take numbers which are greater than 1. To decide whether n is prime number or not, what we have to do? Find largest natural number m such that m into m less than or equal to n. Less than or equal to n. That is first step. Second step, find the all prime numbers less than or equal to m. Less than or equal to m. Step 2, if n is not divisible by each of prime numbers found in step 2, then n is prime. Otherwise, n is not prime. So here, let's try to understand with one example, children. So which of the following numbers are prime? So we have 137 here. Means, so we have to write 137 as a product of two same numbers whose value is less than 137. Suppose 11 into 11, 121. Next, 11 after, we can write it as 12 into 12, 144. This 12 into 12, 144 is more than 137. So that's why lesser value we have taken. 11 into 11. 11 into 11, 121 less than 137. 12 into 12, 144 greater than 137. Okay. So, up to okay. So, we can take 11. So, this is greater than 137. So, what we can do? So, 11 is the largest number such that 11 into 11 less than or equal to 137. Because we have to find the largest number which satisfies this condition, m into m less than or equal to n, where n is the number which we want to find whether it is prime or not. M is the number which satisfies this condition, but it should be the largest number satisfying this condition. So this 11 into 11 or 11 is the largest number which satisfy this condition. So the prime numbers less than or equal to 11 are 2, 3, 5, 7, 11. These 5 are the prime numbers less than or equal to 11. So we have to check whether this 137 is divisible by any of these numbers or not, according to divisibility rules. So if we check this 137 not divisible by 2, because in units place we have 7. Not divisible by 3 because sum of all digits is 11. Not divisible by 5 because in unit digit we don't have 5 or 0. Like that we have to check all. It is not divisible by any of the factors of any of prime numbers less than 11. So we can tell it is a prime number. We can tell it is a prime number. Next, 331. 18 into 18, 324. 19 into 19, 361. So this is a bigger number. No need to consider this. Smaller number, this one we can consider. 18 into 18, 324 less than 331. So 18 is the largest number satisfying this condition. Satisfying this condition. Next, the prime numbers less than or equal to 18 are 2, 3, 5, 7, 11, 13, 17. So this 331 not divisible by any of these prime numbers. So it is not divisible by any number. So it is a prime number. So it is a prime number. So like that we can do, children. Or this 527. 527. 527 we can write it as 17 into 31 equal to 527. Means 527, this 17 and 31 are the factors of 527. So but prime number means it should has only 1 and that number. 1 and 527 as factors. But here we have other numbers also. So it is not a prime number. It is not a prime number. Okay, children. Like that, some divisibility rules we have cross-checked today. We have learned today, and we have checked whether a number is prime or not, basing on this rule. Okay, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.